the viewers. Hope you are all well during this tough situation. Please stay home and stay safe and keep following the government's guideline. So myself Sayan Mujumdar, on behalf of Science Academy, I want to start the second video session, which is about the chemical bonding, the basics. So let's start with the chapter. So what does the deals with chemical bonding? So bonding is a force that tightly holds the atom together to form a molecule. So we have to know the previous outcomes of bonding, like 1812 Berzelius said that the bonding occurs between the two opposite charge atom. That means one cation and another is anion. In 1952, Franklin suggested that there is a chemical combination or valency that helps to form a chemical bonding. So before starting the chapter bonding, we have to know about the electronic configuration, like the arrangement of electron between the orbit on any atom. So we basically know that there is K, L, M, N. These are all the orbit or shells. So the electronic arrangement there is occurred by the formula 2n square, like 2, 8, 18. So the valency that is fully depend on the number of electron present in the outermost shell. Like if there is the number of electron 2 at the outermost shell, the valency will be 2. If the number will be 3, then the valency should be 3. And if the number is greater than 4, then what does occur? So we have to know that thing. According to the electronic theory of valency, any atom before the formation of bonding have a tendency to acquire the inert gas configuration. That means they should have 8 electron at the outermost shell, and that is the electronic configuration, that is the most stable configuration, and that is the less energetic configuration. So to form the 8 electron at the or octet in the outermost shell, the electron or the atom processes two follows. That is mutual sharing of electron. Another is direct transfer. So we can divide chemical bonding that depends on these processes by 3 types. What are those? They are ionic bond, covalent bond and metallic bond. So let's start with the electronic configuration. For ionic bond, there should be a presence of ion to form a ionic bond. What are those ions? One is positive ion, another is negative ion. Basically, ionic bond is named after the bond which are formed by ions. Like one will be cation, another will be anion. So, and there should be a huge difference between electron affinity and ionization potential. They are not equal, and there should be a huge difference to form an ionic bond. For example, we can take NaCl. Sodium chloride, we every time know that sodium chloride is a table salt and it is an ionic structure and it is very much stable structure. And what is the cause behind the stability? We have to know by the structure. So firstly, we have to know that how much electron sodium can carry. That is 11. And the normal electronic configuration of sodium is 2, 8, 1. That means the K cell contain 2 electron, L cell contain 8 electron, M cell contain 1 electron. And during chlorine, it contains 17 electron. Here K cell contain 2 electron, L cell contain 8 electron and M cell contain 7 electron. So this is the general electronic configuration of sodium and chlorine. And what happens during the formation of bond? They are in neutral condition. they should have to form an ion to form a ionic bond. How does they form? So previously I said that before the formation of bond, they should have to acquire the formation of inert gas. So they should have to present outermost shell with 8 electron or octet. So if sodium release 1 electron, then what happened? The 2, 8, 1 electronic arrangement become 2, 8. That acquire the configuration of neon. Previously, the configuration of sodium was neon and 3s1. What does happen next? The 3s1 or the electron from third orbital is released. Then it acquired the configuration of neon gas. And what happened to chlorine? Basically, chlorine contains 17 electrons. The configuration was 2, 8 and 7. That means neon 3s2 3p5. What happened next? Chlorine captured the electron which has been previously released from sodium and form Cl-. Now what does happen? The chlorine acquire the configuration of argon. So now it has formed the two ions, that is Na plus and Cl-, and that can form NaCl. So this is the basic behind formation of ionic bond. So what does it happened? So why Na and Cl particularly follow the formation of ionic bond? Previously I said that there should be a huge difference between ionization potential and electron affinity. For sodium, it have an ionization potential around 5 electron volt and electron affinity around 0.5 electron volt. For chlorine, the ionization potential is 10 electron volt and electron affinity is 4 electron volt. So you can see there is a large difference between the ionization potential and electron affinity. So they should have to form an ionic bond for being stable. So now you have to know the general structure, that how to draw a Lewis structure for ionic bond. So basically during the formation of Lewis structure, we have to only take the electrons of outermost shell. Like the sodium contain 1 electron in the outermost shell, so we can denote by a cross sign, and the chlorine contains 7 electron in the outermost shell, so we can here denote by a dot sign. So basically what is happening, this electron from sodium is transferred to chlorine and now it is formed that Na plus and Cl minus. So both can acquire the octet configuration in the outermost shell, and now that is fully ready to make an ionic bond. So that is the formation of ionic bond. Now move to the second example of ionic bond. What does happen if the metal ion have a valency of 2? We can take example of CuCl2 or CaCl2, like calcium chloride. We can take surely the example calcium chloride. Calcium have an outside electron, that is 2. So we all know that calcium contain 20 electron. What is the configuration? 2, 8, 8, 2. So basically it contains the configuration of argon and 4s2. And we know that with the previous example, chlorine's configuration, it contains 17 electron, it contains neon 3s2 3p5, that like configuration. So one atom of chlorine can take only 1 electron to form an octet, but here calcium is releasing 2 electrons. So how much chlorine needed? It should be a minimum of 2 chlorine need to form an ionic bond between calcium and chloride. So what should be the structure? Calcium releases 2 electrons, and that is the basic reaction of calcium and chlorine. Here, after releasing 2 electrons, calcium gets a configuration of argon gas, and chlorine also gets the configuration of argon gas. So we can draw the structure as if we draw the electron of calcium in cross structure and electron of chlorine in dot structure. One electron transferred to this chlorine, another electron is transferred to this chlorine. So that's why there is the formation of 1:2 complex between calcium chloride. Now move to the second type of chemical bonding. What is covalent bonding? Where there is a less difference between ionization energy and electron affinity. What does happen? There should be a mutual sharing of electron pair. Basically, there is ionization potential and electron affinity nearly same. So what does this happen? There happen a mutual sharing of electron. Electron pairs, and the number of pairs shared between atoms, that is equal to the number of bond formation. So let's start with an example. We can exactly follow that the homonuclear diatomic molecule or any heteroatomic molecule can form the covalent bonding. Like we can take O2. For oxygen can carry a number of 8 electrons. And what is the configuration? 1s2, 2s2, 2p4. That means there is 6 electrons in the outermost shell. So what does happen between two oxygens? So both of the oxygen has shared 2 electrons or 2 electron pairs. Now we can say that every electron have acquired the octet formation. The oxygen which you can count that it has also octet configuration. This oxygen which also have octet configuration. So both have completed octet configuration. Now ready to form a covalent bond between oxygen. Like others example like N2, Cl2, we all can accept that there is the formation of covalent. Let's move from the covalent bond to the third type, that is metallic bond. This is very small type that happens between pure metal and the conductance electron. When the metal is positively charged and the electron that can conduct electricity, that form a metallic bond, and that is specially a electrostatic attractive force between the positive charge atom and electron. So that was the basic class for bonding. The next advanced class will be uploaded soon. Please follow, like, share and subscribe our channel, and please keep watching our channel.